Hello everyone. Today my topic is conjugacy in algebra. I'm B. Shafina Banu, Assistant Professor of Mathematics, Jamal Mohammed College. The first definition of this session is conjugate of an element. If A be in G, then we have to say B is conjugate to A in G if it satisfies the condition B equal to C inverse AC where C in G. This conjugate of an element denoted by A tilde B. The tilde symbol mentions the conjugate of an element. The next lemma, conjugate is an equivalence relation on G. We all know that equivalence relation has three conditions: reflexive, symmetric and transitive. So we have to prove here is conjugacy satisfies the three conditions: reflexive, symmetric and transitive. So let G be a group for all A, B, C in G. The first we have to prove is reflexive, that is to prove A tilde A. In that we all know that E in G and E equal to E inverse. So we have to write A equal to E inverse AE. Hence A tilde A. Therefore tilde is reflexive. The next condition is symmetric. In this we have a condition if A is tilde B. So we have the equation B equal to X inverse AX for some X in G. Then we have to prove B tilde A. For that we have to pre-multiply by X inverse the whole inverse on both sides. From the above equation we get AX equal to X inverse the whole inverse B. And post multiply by X inverse on both sides we get A equal to X inverse the whole inverse B X inverse. Let Y equal to X inverse, then we have to write the above equation as A equal to Y inverse BY. Hence tilde is symmetric. The last condition of equivalence relation is transitive. That is, if A tilde B and B tilde C are the conditions, we have to prove A tilde C. Let A tilde B gives the equation B equal to X inverse AX and B tilde C have an equation C equal to Y inverse BY. In that equation we have to substitute the value of B. We get the equation C equal to XY the whole inverse AXY. Hence A tilde C, that is tilde is transitive. Here we have to prove tilde satisfies reflexive, symmetric and transitive, and so tilde satisfies the equivalence relation. Hence conjugacy is an equivalence relation on G. The last definition of this session is conjugate class of A. For A in G, let C of A equal to set of all X in G such that A tilde X, that is every element of G satisfies the conjugate condition with A. Then that elements are all collected to this set capital C of A. The equivalence class of a conjugate relation also satisfying this set, we get the conjugate class of A, that is C of A. Finally, thank you.